Medical researchers found that people who take aspirin take on average 8.6 tablets per week. A medical doctor wanted to see if he could reduce the number of aspirin tablets a person consumes if the subjects practice yoga twice a week. A random sample of 7 people who took aspirin were taught yoga, and after a 12-week period, the doctor found that they took the following number of tablets for 1 week. Test the claim at alpha equals 0.01. Assume the variable is normally distributed. Okay. Let's write our claim first, which is the alternative hypothesis. Medical researchers found, a medical doctor wanted to see if he can reduce the number of aspirin tablets a person consumes if that person practices yoga twice a week. We want to reduce the number of aspirin tablets from the average of 8.6 tablets per week. So for our claim, we're going to say that mu is less than 8.6 tablets. Now, the null hypothesis states that there is no difference between a parameter and a specified value. If there is no difference, that means they are equal. So mu is equal to 8.6. Number 2, we want to find the critical values. And we must ask ourselves the question, is the population standard deviation known? If you are reading the question, there is no mention of a standard deviation. Because the question does not mention the standard deviation, that means the answer is no. We do not know the population standard deviation. Because sigma is unknown, this is a t-test. The direction of this test is a left tail test. So one tail to the left. The alpha level is 0.01. Because this is a t-test, I must find the degrees of freedom. We have a random sample of 7 people. So my degrees of freedom is going to be 1 less than that. 7 minus 1, which is 6. Remember, this is a left tail test, so the critical value needs to be negative. Let's go on to the t-distribution. It is a one-tailed alpha, 0.01. Degrees of freedom is 6. Clear this out the way. One-tailed, alpha level 0.01. Degrees of freedom is 6. And that critical value from this table says 3.143. But because this is a left tail test, that is going to be negative 3.143. Now, the next step is we want to compute our test value. However, the only thing that we know off the back is the population mean, which is stated in the null hypothesis, which is 8.6. And we know the sample size because we're looking at 7 people. However, when we read this question, we are not given the sample mean. We are not given a standard deviation at all. But we are given a data set. And based on this data set, we can find the sample mean, which is X bar. And based on this data set, we can also find the sample standard deviation. Just like we did for question number 10 in confidence intervals. So let's make our table, which is like this. The numbers are already in our table. And let's add up our numbers. Put this down here. Scroll this up a little bit. So to find the sum of x, that is going to be 7 plus 4 plus 6 plus 8, 9 plus 9 plus 5. That equals to 48. Now, I want to complete the table. I want to find the sum of x squared, which means I must square these values first and then add them together. 7 squared is 49. 4 squared is 16. 6 squared is 36. 8 squared is 64. 9 squared is 81. 5 squared is 25. Let's add those squares together. And we get 352. Now we need to find our mean first. Come on, man. This gets me upset sometimes. And to find our mean, that is the sum of our data divided by n. And n is how many values we have. We have 7 values. And the sum of our data is 48. So that is going to equal to 48 divided by n, which is 7. 48 divided by 7. Let's take one number after the decimal. That will be approximately... I want to take two numbers after the decimal. I'm sorry. One number after the decimal. Approximately 6.9. Now, we need to find our standard deviation for our sample. Put this over here. And let's plug in the values. S is equal to the square root of n, which is 7, times the sum of x squared. The sum of x squared is 352. Minus the sum of x. The sum of our data is 48. But that is being squared. Let's divide it by n, which is 7. And parentheses, n minus 1. 7 minus 1. Times 352. That's 2464. 48 squared. That is 2304. Divided by 7 times 6. Because 7 minus 1 is 6. When we do the top, that's going to be 160. When we do the bottom, that is going to be 42. 160 divided by 42. That is approximately 3.81. I'm going to just take 3.8. No, 3.81. Because a 9 will make that 0 round up to a 1. And then the square root of 3.81 is 1.95. In class, I may have did 3.8, but I'm gonna do 1.95. So now we have all that we need to compute our test value. Our test value is t is equal to the sample mean, and the sample mean is 6.9, minus the population mean, the overall mean, which is 8.6, divided by the sample standard deviation, which is 1.95, divided by the square root of my sample size, and my sample size is 7. And my numerator, 6.9 minus 8.6 is negative 1.7. 1.95 divided by the square root of 7. Let's take 3 numbers after the decimal. So it's going to be 0.737. Let's divide the top and round to 3 numbers after the decimal. Negative 1.7 divided by 0.737. T is equal to negative 2.307. And that is how we computed our test value. Step number 4 is going to be make our decision. Draw the bell-shaped curve. This is a left tail test, so let's place our critical value on the left side. Remember, the critical value in step number 2 was negative 3.143. Shade in. Now remember, if our test value lands within the shaded area, we reject the null hypothesis. If our test value lands in the non-shaded area, we do not reject the null hypothesis. Our test value is negative 2.307. That will land on the left side, but it'll land over here. And because it does not fall within the critical region, we do not reject the null hypothesis. And when we do not reject the null hypothesis and write our summarization, we state that there is not enough evidence to support the claim. There is not enough evidence to support the claim that practicing yoga can reduce the amount of tablets taken, my handwriting is awful, a week from 8.6. And that is it to the traditional method. Next type of method we're going to focus on is the p-value method. I'll see you around. Take care.